We'll be talking about Hardy-Weinberg equilibrium and how this can shift due to different types of selection. So first off, we're going to start with our population, which will focus on moths. There is a thriving population of moths present on an island off the coast of England. They're brown, black, and white moths present in a forest environment. Brown color makes it very easy to blend in and survive until the Industrial Revolution hits. So we do know they are diploid and that the population size is 1,200. The gene is wing color. There are 2 alleles and genotypes, and the phenotypes are listed. So these are the number in each population depending on the phenotype. And to find if this population is in Hardy-Weinberg equilibrium, we simply find the frequency of big B and the frequency of little b, which ends up being for big B 0.6 and for little b 0.4, which adds together to equal 1, which is good. And then it also equals out within the Hardy-Weinberg equation. The allele frequencies, as we saw from earlier, P is representative of big B, it's 0.6, Q is representative of 0.4. So the allele frequency comes out to 0.6 big B plus 0.4 little b. Genotype frequencies, we find these by using the Hardy-Weinberg equation. So P squared will be your black, so that's 0.36. Brown is 2PQ, which comes out to 0.48. And then your white moth is your Q squared, which is 0.16. So now the Industrial Revolution has hit and we observe a form of selection occurring. So these are your pre-selection frequencies, which we saw in the earlier slide. So these are the relative fitness, which is just how well one is going to survive. Survivors unadjusted has been calculated. So you multiply the relative fitness by the frequency. You then add these together to get your average fitness, which is the sum of them. And then take your survivors unadjusted and divide it by the average fitness to get your frequency after selection. So now this is done. The new allele frequencies are now, you find it by, for F big B, take the frequency of black and then half the frequency of brown, and you find that it's 0.6387. And then you can do the same thing for F little b, or you can do F little b is equal to 1 minus the frequency of big B. So you come out to 0.3614. And then for new genotype frequencies we saw on the last table, when we took the survivor unadjusted and divided it by the average fitness. So it's 0.4025 big B, 0.4723 big B, little b, and then 0.1252 little b. So what type of selection is this? It is a directional selection. This simply is from one allele being favored in the terms of survival. So when the Industrial Revolution hit, there was more coal, more ash. So black moths were now blending in better, and they were able to camouflage and not be killed or harmed by their environment. Whereas white moths were killed faster, and then brown moths could somewhat blend in, but not as well as they used to could. This is in fact based off a true story. And the diagram at the bottom shows how directional selection occurs. These are my references.